Hi, my name is Pappy Bedard, and in this tutorial I want to explain to you how I gained my understanding of the formula field. Now this is a kind of a long tutorial, so I apologize for that. What I wanted to do was to try to understand how I could create these mathematical curves and surfaces that would be almost impossible to do in any other type of modeling, except for by using a formula. So here goes. So how do I go about understanding something like the formula field? Well, let's start out by adding a field. If you're in R20, you can create a field and pick a formula field. But if you're in R21, you can click this button and choose formula field. So there's the field. Gee, it's kind of hard to understand what it is by looking at it. One thing that I've found is that if we put the field in a volume, there's other ways we can view it. So I'm going to create a volume builder and drop the formula field under it. All right, now we can see something. Well, you could see over here that it comes default with this crazy formula here. Let's just see what that does. I see it's got some variables in here like ID, count, D, and F. Let's see what those variables are by twirling this open. So let's see, ID is the component index. D is the delta time, and F is this frequency. Okay, since it's got time in it, let's hit play and see what happens. Okay, that's interesting, but it doesn't really help me learn what this is. I'm going to start by trying to figure out what all these fields actually are. So I'm going to delete this formula. And let's just put px in there and just see what we get. Okay, that's interesting. If I click on the volume builder and then formula field here, I want to see what size it is. Okay, it's a 200 centimeter square, but that's just the size in the volume builder. A field is actually infinite. So to make this easier to visualize what's going on, I'm going to add a cube, which is by default 200 centimeters cubed. And to make this even easier, I will put that in an atom array by holding down Alt. And I'll get rid of those little spheres on the end by changing this radius to 2. So that gives us the box that's the same size as the field. So going back to formula field, by putting px in the formula, we see that we have something from approximately 0 all the way out to 200. Well, I know that px is the position, so each point in this field has a position, and I assume that they go from -100 to 100. Well, I know from working with Volume Builder that if a field has 0.5 or less, actually it's this number here, 0.5, the surface threshold, or less, there'll be no voxel. And if it's greater than 0.5, there will be one. Well, that kind of makes sense because the formula field now has px in it. So when the position is anywhere greater than a half, it's going to create a point. Anywhere less than a half, it'll show no point. Another way of looking at that, instead of looking at voxels, is to turn on fog, which shows us individual points. And the color will range from black to white, meaning 0 to 1. And let me just change the voxel size down to something small, like 2, and we get a better sense of that. So this formula field with just a dx in it will show us a value anywhere up. Well, it'll only show the positive values. So go back to sign distance field. And because I changed my voxel size, that looks more like that. All right, so I think we can predict now, if I go back to formula field, what py will do. Yep. Any value that's greater than 0.5 on the y is going to be a point. And pz, obviously, any value of z that's greater than a half is going to show a point. Okay. Let's see. So I'm going to go back to px for a minute. And let's see what happens if I rotate this. If I go to the formula field coordinates and start rotating. Whoa, I'm going a little too fast here, but yeah, okay. So it's using the local coordinate. You could see here's the x direction. So anything greater on that rotation value. Let's see, if I set this to, say, 45. Well, it's only a single number. The rotation value is just one number. So if I go back to the field, if I put in Rx, it's 45 everywhere. Interesting. Let's try minus Rx. Apparently you can't use the rotation and probably the scale. Let me try Sx. Oh, okay. Well, the scale, it's going to be one value everywhere. If I do minus Sx, yeah, that's off. Go back to Sx. And let's just play around with the scale a little bit. So go to the coordinates. I'll click on that S so that they all change. Well, obviously, if it's greater than a half, they're going to be creating a voxel. What happens if they're 0.4? Huh. So that also doesn't work. So I don't think we're going to be able to use scale either as a way to generate geometry within this volume or to assign values. So let me go back to the defaults on all these. And go back to the field and let's try something else. All right, so what is ID? To make this a little bit easier to deal with, let's go back to 10 centimeters here. And let's see if we can figure out what ID is. So I'll just put in ID. I assume ID goes from 1 to some number. Yeah, so they're all above a half. So let's try a little formula. Let's put in a formula like that will return either a 1 or a 0, a true or a false, if ID is greater than 100. That's either going to be true or false for each ID. So all the IDs that are less than 100 will be 0. All the IDs that are greater than 100 will be 1. Let's see what this does. Yeah, so some of the IDs, some of the values disappeared off the bottom here. I wonder if that looks any different in fog mode. Yeah, they don't even exist. Let me change that formula field so that, say, it's greater than 10,000. Well, that's too much. Let's say 1,000. Yeah, okay. So they either don't exist at all or they're 1. So 0 or 1. So I'm going to take a quick look at the help here. I'm right-click on formula and show help. and I want to see what frequency is. Frequency is a number from minus infinity to plus infinity, and it's a multiplier that can be adjusted using a slider. So it's only a multiplier. So let's make this interesting here. So let's just make this 10, and I'll make this 10 times f, which is that frequency down here. So if I change the slider, yeah, I can see it changing. Let me go back to sign distance field, and you'll see that. Back to formula field. So let's say I put 50 in here. I can make this 100 instead of 10. Up here, yeah, so now as I change the slider, yeah, you can see how the points are built up. So I'm going to hold the shift and just slide up and down here. Well, that's kind of interesting. So we can tell from this, if I go slowly, that the IDs start on the lower left there, and as they go up, they go all the way to the top. Then they start at the bottom of the next row. So that's how those IDs are arranged, if we ever find a way to use that. I'm not sure yet. Count, that's the total number of IDs. So let's say if the ID is greater than the count divided by 2. That should be exactly half. So there we are. So that's half the values. Count divided by 2. And subfields are the fall off weight. So I assume if we have a fall off, a subfield, let's make a linear field. Right there. And then use that value. So right now this equation is returning either a 1 or a 0. It's answering the question, is ID greater than the count over 2? It's either 1 or 0. Well, let's multiply that times the subfield value. What that should do is allow that fall off to affect all the ones. Obviously, if you multiply anything by 0, it's still 0. But on those values that are 1, if you multiply it by some value in the subfield, some of them should become less than 1. And then they'll turn off. And they all turned off. Interesting. Let's see. Oh, I added a group field by mistake. Let me get rid of that. Go back to formula field and add subfield, linear field. Okay. Go back to our formula field. ID. Did I do this right? Spell it right. Let's see what happens if we drag this field. Nothing. All right, what am I doing wrong here? ID is greater than count over 2. Oh, it's called subfields S with an S on it. There we go. Okay. So that now has an effect on... Now, when you're looking at a volume like this, they're either on or off. So it's kind of hard to see what the field is doing. So what I will do is go back to the volume builder and just temporarily now change it back to fog and up to density. And now I'm going to drag this linear field. Yeah, so you can see now that it's affecting our equation. It's taking away, on a gradual way, all of the values that were set. So you can tell again that the formula field turned off all the ones where the ID was less than half the count. So it pulled away all of these. So there's no way to bring those back. But the ones that remain, we're now, again, we're adding a fall off to the ones that remain. Okay. Well, let me delete that linear field and go back to formula field, and let's play around with some more things here. So, all right, how about we do if the ID is greater than the time. So if ID is greater than, let's say, time, well, we know there's a lot of points here. We can tell how many points. Let's see if I go. Let's just say if ID is greater than 0. This should turn on all of the points. It does. And if I click on Volume Builder, right at the bottom here, it says that there are over 1 million voxels. That's a lot. So let me go back to 10 here. Now there's only 9,261 voxels. Okay, 9,000, and I want to look at those according to time. So what I'm going to do is go back to the formula field, and instead of that 0, we'll put in time times 1,000. And let's just see what happens. Time times 1,000 was way too much. Let's try. Oh, it's not time, it's just t. Okay, time times 1,000. So we're saying if the ID is greater than that, let's make it less than that. If the ID is less than time, okay, so they're all less. I'm going to multiply that 1,000 times the frequency down here to make it easier to play around with. So if we increase this frequency, well, right now time is 0, so ID is not going to be less than 0. Let's put it at 1 second, 30. And okay, so that's how many voxels, or that's how much field we're going to have if it's 1 second. 2 seconds should be twice as much, and so on. So let me just hit play. Yeah, that's kind of cool. And of course it stops at the end of my timeline here. Let's do this. I'll go to the end of the timeline, and I'm going to increase my frequency until I fill this cube. Okay, now go to Volume Builder, turn this on to Sign Distance Field, and rewind and hit play. Yeah, so it's like it's building a wall with all these little blocks. That's kind of interesting. I want to put a volume mesher above that just to get a look at how cool that looks. All right, that's interesting. Look at it from the other direction. I like it. So back to the formula field. Let's see what else we can do with this. Obviously, we could do things like this, where the position of x is greater than the position of y. That's going to return either true or false. So let's see if this makes sense. Go back to our standards. So in this spot, x is minus, and y is, yeah, so in this area here that's blank, that's where y is greater than x. Every place else, x is greater than y. By the way, we can always invert that with remapping. If we go to remapping and invert it, Now that just it turns the zeros to ones and ones to zero, basically. Go back to this. What if we say x equals y? I don't know what will happen there. Let's try that. Go back to formula field. Field px equals py. That's going to be a very narrow range. It's probably too narrow to generate a voxel. Let's see if we increase the number of voxels. No, I don't see any. Maybe we could see them if they're fog. No. It would have to be within a range. So let me go back to formula field. Oh, I got the wrong syntax. No, that still doesn't work. Let's say if px is greater than py minus 5, and also in addition px is less than py plus 5. Let's see if that works. Okay. Yeah, that gave me a little slab here. Now let's try something like really crazy. Let's just say sine of x. So we know that that equation is going to return some value. It's px, by the way. Some value between minus 1 and 1, depending on what the value of px is. It'll take px as if it's an angle and calculate the sine of that, and then return somewhere between minus 1 and 1. And what do we have here? Turn off. Let me increase the, no, we are at 1 centimeter. See what that looks like. Oh, I'm still on fog. I'll turn off the mesher. Oh, okay. So it does have some changes in value. I think the formula, the sine takes a angle as radians. Let's convert that to degrees by multiplying by pi over 180. Now I want to assume it's degrees and convert to radians, so it would be pi. So 1 degree is way less radian. Yeah, this will work. Okay. It's also multiplied times py. Oh, now we see some kind of an interesting pattern here. Turn this mesher back on. Change this back to a sine distance field. Cool. One more step. Let's go back to formula field and multiply again times p z. It's taken a little while to calculate this because I've got a very low value for my voxel size. Let's give it another second or two, and then I'll see if I can change it. Let me just go ahead and change this now to 3. See if it'll take. All right. Whoa. That's kind of interesting. Let's go down to 2 and see what that does. Try to clean it up. So it's generating some kind of interesting pattern based on the multiplication of all three axes and getting the sine of that. Well, that's a start. I think I've got a handle on now what each of those values are. So now it's just a matter of coming up with some equations. So I think what I'll do is involve this frequency thing so we can make some scale changes while we're playing around with this. I'm going to cut and paste an equation that I've already looked at. So it's just the sine of position x divided by this value f times 10. So I'm going to set this to 1, and that gives us nothing. Let's start increasing this. Oh, how about decreasing it? 0.2. Okay, that did something. 0.01. Okay. So it just gives us a pattern of on and off depending on whether the sine is 0.5 or less. And of course the ratio is about 1 on to 3 off, because the sine function returns any number between -1 and 1, and we know that anything below a half, 0.5, is going to be off. So there's a lot more off than on. So what we can do is add a half to that. So we put 0.5 plus that, and that should give us 50-50. Yeah, so that now gives us 50-50. What if we multiply px times py? And we'll make that, let's see. Okay, I just changed the frequency to 1. I'm going to hide this atom array for now and the cube. So that's what this field gives us now. And again, with remapping, we can invert it. So every place that's off here can become on and vice versa. Kind of just flips it upside down. Let's play around with some more. Let's say we put all that in parentheses and subtract it from 1. 1 minus that has the same effect as inverting it. Let's add the pz in there, times pz. And it looks like we need to make that much bigger. So I'll multiply that by 10. And let's multiply it again, let's say by 50. Okay, we're starting to get a cool pattern here. Look at that. Let's change sine to cosine. Oh. Now, the reason we're getting these little bits of geometry in between those fins has to do with the way it's meshing with the volume mesher. If we go to volume mesher and change the threshold, make it smaller, yeah, it erodes. Let's see, if we make it bigger, yeah, it fills it in more. If we make it smaller, it takes away some of it. But let's see, if we change adaptive, that just gives it less mesh density. So how could we clean that up? Well, maybe we could just make that number even bigger under the formula field. Instead of 50, let's try 100, double it. Yeah, so that cleaned it up kind of nice. Now, I'm curious about what happens if we move the volume builder, because in the formula field we are using values of px, py, and pz. I wonder if they're local coordinates or global. So let's move the whole thing, the whole volume measure, and see if it changes. No, that doesn't change. That's good. That's good to know. Set this back to 0. Let's move the volume builder. Probably the same thing. Yep. But what if we move the field itself? Interesting. It's already set at minus. Change that to 0. Aha. Now that has an effect. So those values seem to be related to the position of the field. So we could dynamically change that by just sliding the field over. Let's see what happens. Yeah, that is so cool. So we can change where the x's and y's and z's are by stretching and moving that field around. Go back to 0 here. Now in this position, it's kind of very widely spread apart, so we could actually go back to the field and maybe decrease this, maybe down to 30. Get more fins in there. Very cool. Go back to 50. See what I have to do to make it nice and clean looking. That's pretty close. Try 60. And let me go to volume measure and adjust this a little bit. Nope. All right, I'll try 70. Well, that's not bad. Maybe 75 will be perfect. Still got a little few there. Say 70, 75. Oh, they came back. Interesting. So it probably depends where those value points are in relation to where these it probably averages. You know, one way to probably fix that, go back to 75, by just increasing the density count of the volume builder. If I make this 1, it's going to take a little bit longer to generate. But what it would do is put these points closer together and clean that up. Yeah, so that didn't take too long. That's pretty cool. So this is what the field looks like. If I take it out of the volume builder, if I just put it out in the open down here, you can't see it. And that's what I don't like about fields. So if you had a force field, maybe a force field with that same formula in it, you'd be able to see it. Let's try that. So I'll go into the MoGraph tab here and pick a... No, it's actually the simulate. Simulate forces, and I'm going to pick the field force. Now, within this field force, I can create a should be able to create a formula field, right? And let me go to this formula field and copy that and paste it into this field here. Yeah, so we can actually see that. Now, a field force is more than just points. It's also directions. I'm going to hide all of this stuff just so we can concentrate on this field force. I believe we can change the display, the line density. kind of hard to tell that that's the same pattern we were talking about. Maybe if I reduce the box size in one dimension, it won't be so hard to figure out. So I'll change the Z, just shrink it way down. And yeah, you can kind of see it's got that same pattern. I'll increase the density even more. And then I'll move that field. I'm going to make this a little smaller. Oh yeah. I'll move this and we should be able to, oh, see, I have to move the field. Yeah, see, it's moving through those slices of that pattern that we were looking at before. Now, I find this a lot harder to look at. So if you wanted to design a formula field that you use in a field force, I would suggest that you first play around with it in the volume mesher to get a visual feel for what it looks like and what it's going to do. Now, one thing that's I should point out here, all right, we're going to delete this field force and go back here. Put that back under there. Wait a few seconds until it turns on. Put the mesher back on. Actually, I'm going to turn the mesher off. And in the volume builder, I'm going to show vector. And what this is going to do is it shows you the direction. We can change the density of this to make it easier to look at. Let's say 5. Maybe even back to 10. Yeah, so this is the same pattern. We just see fewer points. You can see all of the vectors, one at each of those points, and it's the colors. I could make this much simpler formula to talk about. So let me get rid of the PY and PZ. Okay. How about I go back to sign distance field and come up with a slightly different formula here that's easier to do what I'm trying to explain. I'm trying to come up with a formula here that is going to show what I want. All right, so you remember this pattern. Increase the voxel size, decrease it so we can see it better. All right, so there's a pattern. And let's look at that straight on with no perspective, front view. So we're looking straight through this field. And now turn on vectors. You could see that all of the vectors are pointing towards 0. Every single one of them. And this gradation in scale on each line has to do with the direction of force. I can show you that by going back to the field and remapping and just inverting it. And you see all of these flipped over. So if you wanted to control the direction of all those vectors, you really can't do it with a formula field. Well, you could reverse the direction. Anything more than that, you'd have to use a Python field, which is much more complicated. Back to sign distance field, turn on the volume mesher, go back to my perspective mode. Anyways, this by itself is kind of cool. So now, next what I'm going to do is show you some equations that I've already come up with ahead of time that show you a lot of interesting different patterns. So I was at a used bookstore one time and I ran across this book right here. It's just filled with equations of mathematical curves and surfaces. And I use that as a reference to come up with a couple of ideas here. And I'll show you those. So the first one is called a spire. Cutting and pasting here. So go back to formula field. I'm going to paste that in here. So this gives you something called a spire. And right now, I could shrink this down a little. We could make it a lot smoother in a lot of different ways. If this spire, by the way, goes on forever. So if we go into the volume builder, click on formula field, and make this a lot taller, let's say a Y of 400, it'll just keep going. And again, we can move this field down. And that can go as high and as thin as we want. Now, obviously, you could do something like this with a lathe. You create this curve and then wrap it around a lathe and then add it to a volume builder or whatever you want to do. And that would be a little simpler. I'm going to set this back to 200 and put the formula field coordinate back to 0 on the Y. And let me cut and paste another one. This one is actually called a monkey saddle. This would be a lot harder to model. I'm going to put links to I'll put these formulas in the description of the video. All right, hit enter. So this is actually called, the shape is called a monkey saddle. That would be extremely difficult to model any other way than using a formula. One thing is, you could raise or lower this entire thing by adding or subtracting a number in here. So I'll add 5. That should just raise it up. You could create the bottom half of that by making this greater than instead. And if you put those two together, I'm going to cut and paste this one. It's too much to type. You could actually get everything above the low monkey saddle and below the upper monkey saddle and actually create something like this. Again, you can increase the resolution by adding more or making smaller voxels, or by playing around with the volume mesher, smoothing. Actually, you can add smoothing here, but anyways, so that's how I made that monkey saddle. Can add a nice leather to that, put a monkey on it. Be awesome. That is a long formula, though. Anyways, I'll put links to these in the description, and this was a very quick introduction to this whole subject. What I plan to do is to create another tutorial, and what I will do is focus on the formula deformer, and I'll go through a lot of the other equations that I found in that book. Anyways, thanks for watching, and catch you next time.